All right.
Should I do my own little 3, 2, 1 countdown? I see we've started recording, so that works out nicely for the little notification. Okay, so I don't want to make this too long. Our speaker for this evening is Dr. Adeene Denton, and she's going to be presenting on more outer solar system stuff, in particular Pluto and Charon, and maybe a little bit of a Valentine's-related scientific story.
Thank you so much for the introduction. I'm going to go ahead and try sharing my screen. And hopefully it's going to work. Okay. Can someone confirm that I'm screen sharing successfully, like audibly?
Yes,
Yes.
you are.
Great. Thank you so much. Sorry. I don't often use Google Meet, so I wanted to make sure. Okay, great. Thank you for the introduction and happy Valentine's Day, everyone. It's such a delight to be here today. Yeah, the title of my talk is called Sealed with a Kiss, the Cosmic Romance Behind the Formation of Pluto and its moon, Charon. And this is going to be kind of an overview of some research that myself and my research group at the University of Arizona recently published at the start of January, which was really fun. So I'm going to start with talking a little bit about the background. So as many of us may be aware, New Horizons, when it flew by Pluto in 2015, completely transformed our understanding of both Pluto and Kuiper Belt objects as a whole. So this GIF is the best images that we had of Pluto from the Hubble Space Telescope that were taken back in 2006, I believe, and they revealed this incredible rotating blob that kind of indicated that Pluto has something going on, but it was very hard to say what might actually be going on Pluto until the New Horizons flyby, which revealed an incredibly geologically active surface. This image was actually the image that got me into planetary science and why I did my PhD on Pluto, because I find this picture so captivating. The Pluto that emerged following the flyby is incredibly geologically complex. It's covered in extensive superficial geologic activity like these water ice mountains and nitrogen ice glaciers. It's also covered in this global canyon system. This is one of the best examples of it. That's Virgil Fosse right here. And then, of course, I would be remiss if I didn't talk about Pluto's heart at least a little bit. There's Pluto's heart, Sputnik Planitia, at the center of this image. And Sputnik Planitia is thought to be this massive impact basin, larger than the state of Alaska, that defines Pluto's near side. And I did my PhD studying this basin. I think it's fascinating, and I'm happy to answer questions about it. But we're interested in an even bigger impact than this one today. Specifically, I want to look at Pluto and Charon as a system. So again, this is a Hubble Space Telescope image of Pluto and Charon together. And before I go further, let me clarify my pronunciation of Charon. You can say Charon, many people do. It's just that I personally was a classics major in undergrad, and so I will be doing the Greek and Roman pronunciation throughout, but they are both equally valid. This is just to stave off confusion. So this is the image that we had from Hubble prior to New Horizons, and then the entire system after New Horizons looks like this. So we got not just Pluto in unprecedented detail, but Charon. And by understanding them together, we've been able to try to get a better sense of how this system originated in the first place. And the important thing to think about when it comes to the Pluto-Charon system is that Charon is very large relative to Pluto. It's 50% its size and 12% of its mass, which is quite large. And the system combined has a large amount of angular momentum. And what I mean by that is the angular momentum that is encompassed by the spin rate of Pluto, the spin rate of Charon, and the rate at which Charon orbits Pluto, if you combined all of that into one body, that body would tear itself apart because it would be spinning too fast. It has an unusually large amount of angular momentum. So when we combine these two facts together, the fact that Charon is unusually large and the fact that there's a lot of angular momentum in the system, which means the system at one point had a lot of energy imparted to it, the prevailing theory for how Pluto and Charon formed, as in how Pluto got a moon so large, is that a giant impact occurred, similar to how the Earth got its moon. And that's the image that I'm showing here on the right, is an artist rendition from JPL of how the Earth moon forming impact might have initially occurred. And before I get into why we think it was a giant impact and how we study that, I think it's important to base that discussion on what we know about Pluto and Charon today. What did we learn from New Horizons about Pluto and Charon that allows us to return to this idea of the two bodies colliding early in their history and helps us learn more? Because we can use what we know about them today to try to understand their distant past. So here's what we think we know about the interior structure of Pluto. This is a cross section that I've made. This is very simplified, but it's as up to date as I can make it. So I'm going to start from the bottom of this cross section and work my way up. So let's first talk about Pluto's core. We are pretty certain about the size of Pluto's core. Specifically, we think that the radius of the core is around 870 kilometers, which would put it at around 2/3 of Pluto. So Pluto is 2/3 rock, 1/3 ice. And we're pretty sure we know that because New Horizons gave us improved estimates of the size of Pluto and its mass. And then from that, you can get its density. And from its density, we can then start to estimate how much of that mass is in rock versus ice. So if you do all that, Pluto is approximately 2/3 rock. But the thing is, we don't know what kind of rock that is. Hydrothermal alteration, misspelled that. Hydrothermal alteration has been suggested from thermal models, which look at how Pluto evolved over time. But the problem is, right now, there's no way to really know the composition of Pluto's core. If it experienced a lot of hydrothermal alteration early on, which would be if the rock in Pluto's core interacted with a bunch of liquid water, then you could change its composition, change its density, and a lot of other things. But this is mainly of interest to us because if Pluto's experienced hydrothermal alteration, you kick off a lot of additional chemical processes, kick off a lot of additional elements that get put into Pluto's potentially liquid water ocean, which could then make it habitable. All of this is interesting, but very difficult to prove. So Pluto's core, maybe hydrated, maybe not, definitely a rock of some kind. When we move further up, we get to a really fun question, which is, was there an ocean? And is there an ocean on Pluto today? There are actually several lines of geologic evidence that point to yes, Pluto, not only did it have an ocean in the past, but it has one right now. And the first line of evidence is extensional tectonics. So the lines on this image here, which are in red, green, and yellow, and a few of them are in pink, these have been mapped across the images of Pluto that we have, and they've been interpreted as extensional tectonics, meaning these formed from the ice shell getting literally pulled apart. And the most likely source for extensional tectonics from the ice shell expanding would be if the ocean is freezing, because as water freezes into ice, it actually expands in volume. So the ocean might still be there, but if it's slowly freezing over time, then that generates a stress on the ice shell that would then be expressed as these fractures. So that's one line of evidence. The other line of evidence is Sputnik Planitia itself and the fact that it is where it's currently located. I'm not going to get into this in a lot of detail in this talk, though I am happy to talk about it. But we think that Sputnik Planitia is a potential positive mass anomaly in terms of Pluto's overall gravitational field. And what I mean by that is it has more mass than it should. Specifically, an impact basin, which is what we think it is, should be a hole in the ground, right? You form an impact basin by something large hitting Pluto and literally excavating material and making a hole. If that's the case, you're removing mass. So you should have a negative signature in the gravity data. But if that were the case, Sputnik Planitia wouldn't be where it's currently located. Positive mass anomalies is when there's extra mass. So instead of having a negative mass anomaly, there's a positive mass anomaly from extra mass underlying Sputnik Planitia. And we think the mass contributions to that extra mass are not just the nitrogen ice that's filling the basin today. That's the white that's that makes the actual heart, but also liquid water underneath the ice shell flowing up underneath Sputnik Planitia, because water being more dense than ice can contribute that extra mass. And that's how you get Sputnik Planitia near the equator, which is where all positive mass anomalies in the solar system tend to reside. Another example of a positive mass anomaly would be the Tharsis volcanic complex on Mars. There's so much mass on that one section of Mars that Mars has reoriented itself to put all of that extra mass at the equator. We think something similar happened with Sputnik Planitia, which is really close to the equator and the tidal axis, which is that red arrow labeled 180 degrees east. The problem is both of these are kind of circumstantial, right? Sputnik Planitia is where it is, but it could just be there. And there's extensional tectonics, but does that mean an ocean is there or not? It's really hard to say. And then when we get up to the ice shell, the structure of the ice shell is also pretty unknown. We are fairly confident, I will say this, that Pluto's ice shell is water ice. So just H2O, frozen H2O with a thin veneer of volatile ices. And the volatile ices are the stuff that is unstable at any warmer temperatures than Pluto. So carbon dioxide, nitrogen, ammonia, some methane, stuff like that. And there's just not very much of this. It forms a thin veneer relative to the entire thickness of the ice shell, which is anywhere from 50 to 300 kilometers thick, depending on how you measure it and whether or not there's an ocean. So that's a lot of ice shell. And then the actual volatile ices are a very small amount. And most of that volatile ice is concentrated in the nitrogen ice glacier that's currently filling Sputnik Planitia today. We think that ice shell might be cold and stiff because, as you know, ice on Earth flows pretty readily at Earth temperatures. This is best exemplified by glaciers, but also the ice sheets in Greenland and Antarctica. When the surface temperature of Pluto is 44 Kelvin, so only 44 degrees above absolute zero, the ice is thought to behave much more like rock, to be cold and stiff. And that's why it can support topography like those mountains that I showed you. But we don't know how cold or how stiff. So the main takeaway here is that the temperature structure and the total thickness of this ice shell are pretty unconstrained. We know that the ice shell is pretty thick, but we don't know how thick and how warm it is because it's really hard to pin down how Pluto might have evolved thermally over time. So to pull that all together, the major unknowns in Pluto's interior are whether Pluto had an ocean and it has one today, whether how thick that ocean is. Is it a thin ocean? Is it a thick ocean? What is the composition of Pluto's core? Is it just rock? Has it experienced some form of hydrothermal alteration that could release elements into the ocean that could then make Pluto a suitable place for life? That's hard to say as well. And lastly, how thick is Pluto's ice shell really, and how is it structured? How can we get a better handle on the ice shell, which is the only part of Pluto that we can actually see? But again, we're only seeing the surface, which is a small portion of an ice shell that's probably hundreds of kilometers thick. The cool thing is, not only are all of these testable parameters, all of these relate to the initial formation of Pluto and Charon, because that initial impact is what sets the stage for all the subsequent geologic activity. So if we can understand the first thing that happened in the system, which would be Charon's capture, we can try to get a better handle on all of these other questions too. And I'd be remiss if I didn't also talk about the major unknowns in Charon's interior. So this is a cross-section of Charon. And we understand Charon a lot less well. Part of this is because, again, New Horizons did a flyby of Pluto, and Charon was also there. But we flew much closer to Pluto. We have much better image data. Charon, it's a little bit harder to tell. We are pretty confident that the outer layer of Charon is ice, but maybe with some rock. It's about 50% rock, 50% ice by mass, we think. And probably it is differentiated, meaning it has a rocky core and an ice shell. But in this case, right, you have a much smaller rocky core in comparison to Pluto. The problem is we're not really sure if that ice and rock are mixed or not. And also if it has a thin remnant ocean. So there's this light blue periwinkle-ish color here for this thin strip of potential remnant ocean. Charon may have had an ocean in its very early stages. we are pretty certain it doesn't have one now because it's just too small. It doesn't have enough heat sources to generate it. But if it had an ocean early on, that could explain why it has that equatorial latitudinal band of canyons that you can see on the left side of this image. That equatorial band of canyons is thought to also be an extensional feature formed by an ocean freezing. Is there any of it left? We don't know. And then how destructive was that initial Pluto Charon impact? If you capture Charon in a giant impact, was Charon initially much more massive? Did it have a lot more rock and ice that it then loses in the process? Is Charon what we would call a primordial Kuiper belt object that retains an ancient structure of forming somewhere else in the Kuiper belt before colliding with Pluto? Or did the collision with Pluto transform it entirely? We aren't quite sure about that. But that process could then dictate Charon's subsequent geologic evolution. So it's important to think about. Now, the main motivating question behind this work is writ large. We want to know how Pluto got Charon and how that influenced their subsequent evolution. And that's a pretty big question that I cannot fully answer tonight, and I did not fully answer in our scientific paper. But we can get a lot closer by investigating that initial collision further. And that's because giant impacts offer us a way to take a look inside bodies that we otherwise would only see from the outside. These are the images we have, and there's so much we can learn. But if we want to dig deeper into the subsurface, we've got to find a way to look inside. So why are we revisiting this theory at all? It's important to ask this question. The idea that Pluto captured Charon from a giant impact has been around actually since the 80s. Charon was initially discovered in, I want to say 1978, but I could be wrong, at the Naval Observatory. And ever since people initially realized how massive it was and how much angular momentum was in the system, this idea has been around, which means we've been iterating on this idea for quite some time. But here's the thing. The moon forming impact, which is the idea that a Mars-sized object hit the Earth and then we capture something and it becomes the moon, that concept forms the foundation for our understanding of satellite capture. And rightly so, because in the case of the Earth-Moon system, we have a lot more information, right? We have plenty of rocks from the Earth, but we also have loads of rocks from the moon, which allows us to do detailed chemical analyses of how similar the Earth and the moon are, which allows us to fine tune the idea of how that collision took place and how material got mixed, et cetera, et cetera, et cetera. But satellite capture might operate differently across the solar system, and that's going to be true for a variety of reasons. This is one of the best models to date of the Earth-Moon forming impact, just so we have a baseline. So Theia, the Mars-sized object, is going to come in from the left and collide with this proto-Earth, releasing a massive shockwave. The most important thing that you will notice here is that both bodies immediately start to act like fluids. They look kind of like blobs in a lava lamp. Oh, and also this is colored by temperature. And the Earth is essentially mostly molten at this point, and so is the moon. Also, look at what happened to that object that hit the Earth. It loses a bunch of its mass, some of it to the Earth. And then we have this much smaller object that's coming around orbiting right now that's going to eventually coalesce to form the moon. So the important things about the Earth-Moon system are that there's a ton of melting and a ton of vaporization. And both the Earth and the moon have what we call global magma oceans because it's a bunch of molten rock. So what you're seeing here is just the first stage in the subsequent evolution of the Earth-Moon system. But that's the idea that forms the foundation for how satellite capture might happen everywhere, and we're not going to watch a second time. But the important thing to take from that video is that in the Earth-Moon collision, we can assume that both the Earth and the moon behave like fluids because the collision is so intense that both bodies experience widespread melting and vaporization. So we can approximate them in our simulations as fluids. And this is going to get into a little bit of how we do simulations and the nuances of why we do the models the way we do. When we think about applying the Earth-Moon system to Pluto and Charon, it's important to remember that Pluto is pretty small. This is one of the reasons it's not a planet anymore. It's only about 17% the mass of the moon. And at that size, we've run a lot of simulations over the past 5 years, myself and my group, looking at giant impacts between bodies at the size of the Earth and the moon and at the size of Pluto and Charon and anywhere in between. And what we found is that material strength is important, but its effects are complicated. And before I go on, I do want to clarify what I mean by material strength. The video that I just showed you approximated the Earth and the moon as fluids, which means they have no material strength, that they act like water. You hit something that is a fluid and it deforms immediately, and it deforms very rapidly. When you instead hit something that has material strength, there's a threshold that you must exceed before it fails. The material strength of any body is just the amount of force you apply to it before it fails. A rock is stronger than ice, for example. We know this intuitively, but we can also quantify that. And in quantifying that, we know their material strength. So at the size of Pluto and Charon, we know that material strength is important. We know that you might not be able to approximate them as fluids, but understanding how to approximate these collisions and doing so accurately is very important, because the outcomes of these giant impacts, including whether Charon gets captured as a satellite, reflects the composition and internal structure of both bodies prior to the collision. So how much ice Pluto and Charon have relative to their rock and how warm they are, stuff like that will affect the collision outcome, including whether or not Charon gets captured. And what that means is we can use giant impacts to inform our understanding of both thermal and mechanical variations in Pluto's interior. We can tie what we think its current composition is back to the past. So previous simulations have been done of Pluto and Charon, and these are from a paper that was done in 2011, which is the last time anybody bothered to do this. And Pluto and Charon are approximated as fluids. So in this first frame, Pluto is the larger body, Charon is the smaller body, and the two bodies collide, and what happens is the force of the collision causes massive global deformation. This is Charon. I've circled in red because it's much easier than me moving my cursor around. These areas where I've circled in red, this is Charon experiencing global shearing. It's getting almost pulled apart by Pluto before it finally gets captured as a satellite in the last image on the lower right. And the reason it's able to deform on such a global scale is because Pluto and Charon are both being approximated as fluids. What I've done in my work is rebuild Pluto and Charon once again, beginning from those previous assumptions and then incorporating material strength. So this is a basic schematic of what my simulations look like. So on the left, we have the target, which is Proto-Pluto, and on the right, we have the impactor, which is Proto-Charon, which collides with Proto-Pluto. And the first thing to note is that the cores of both bodies, which are both assumed to be rock, are in dark blue, and the ice shells are in light blue, almost white. For the purposes of everything I'm going to show you today, we basically hold the interior structures of both bodies constant. So they're both around 85% rock, 15% ice. This got tweaked later to make it more accurate, but the videos that I'm going to show you will be like this. Then we send Charon careening into Pluto at a range of different impact angles and impact velocities. So this image shows you how impact angle works. Charon will always hit Pluto, and there will be a point at which the two bodies are roughly perpendicular to each other, but Charon is traveling in this direction. And this angle here is the impact angle. And the velocities at which the two bodies collide depend mostly on their mutual escape velocity. So it's not, when we think about giant impacts, the speed at which they collide is very different from, say, an asteroid hitting the Earth. An asteroid hitting the Earth is so much less massive than the Earth that the gravitational field of the Earth is much, much more important. And so we basically have a constant estimate of the velocity at which an asteroid would hit the Earth. It's always going to be around, I think it's 15 kilometers per second. For two bodies that are colliding that are similar in size, it's the mutual gravitational attraction between them. And the thing is, remember, Pluto and Charon are relatively small, and they're made of rock and ice instead of rock and metal. So that number is actually going to be pretty small, meaning they're colliding at around 1 kilometer per second. And if that sounds really fast to you, and it is, that's slower than a fighter jet. It's actually not very fast at all. And the last thing I will say about this image is you will note on the top left, there is an arrow. Pluto is spinning prior to the collision. We think it would be rotating prior to the collision. We just don't know how fast. So Pluto is spinning towards the right, and we test a variety of spin rates to see what happens because, as you may know, Kuiper Belt objects have variable spin rates. From Pluto's spin today is pretty slow, but the Kuiper Belt object Haumea, for example, has a spin rate of around 4 hours. It's spinning very fast. So anything could be possible. We're not quite sure. So what I do is I build a bunch of Pluto and Charons in the computer, and then I smash them against each other. I build this whole army of Plutos, and then I effectively blow them all up. So here is a video of what that looks like. That is not true. That is not what my videos actually look like, but it would be cool if they did. I want to show you some of my actual results now and talk a little bit about why they look the way they do. So what we found is that when we put in material strength into this collision, and by material strength, again, I'm just telling the rock in Pluto's core to behave like rock and the ice in Pluto's ice shell to behave like ice. What we find is that we can still get Charon as a satellite, but the way that happens is completely different from those screenshots that I showed you before, where Charon comes in and they both radically deform like blobs, and then eventually Charon ends up captured. That's not what happens when material strength is included. What we found is that internal strength produces this new satellite capture regime that we hadn't ever really seen before, that we're calling the kiss and capture. And that's the romance part of this talk. So on the left, I have the conditions at which this particular video that I'm going to show you is under. So Charon is going to come in from the right at an impact angle of 45. That's important because the average impact angle at which stuff hits each other in the solar system is 45. Why? Basic geometry, it is between 0 and 90 degrees. It's a bell curve. So material in this video is going to be colored according to composition and body of origin. So in this case, we're looking at Pluto. The blue is Pluto's core. The yellow is Pluto's ice shell. Charon will come in from the top right at 45 degrees, and it will have a purple core, and it will have a green ice shell. They're colliding at close to 1 kilometer per second, and Pluto is spinning pretty rapidly at around 3 hours. So now I'm going to show you the video of how Pluto captures Charon from a giant impact. So this was surprising to us for several reasons. So I'm going to show the video again, hopefully without sound this time. So Pluto and Charon collide, and then they briefly merge. They're co-rotating as one body here. And then eventually Charon kind of pushes off and establishes itself as a satellite. What's interesting about this is many things, actually. The fact that Charon remains entirely intact during this process, the fact that both Pluto and Charon lose relatively small amounts of their masses, the fact that that orbit that I just showed you, I'm going to play it again because I love this video so much. As Charon starts to separate, it's going to establish this close low eccentricity orbit that's really circular. So this system stabilizes within 60 hours after the initial impact. So time is on the upper left of this video. We ran this out for 60 simulation hours, which these simulations take about a month and a half on the high performance computing cluster at the University of Arizona. And the resulting system is remarkably stable. So I'm going to step through these in more detail so that we can discuss this. So the first thing that happens is in the first half an hour after impact, Charon has come in, collided with Pluto, and it's been able to partially penetrate through the ice shell. That's what's happening here. So again, the core of Pluto is in blue, the core of Charon is in purple, and then their ice shells are yellow and green, respectively. Then the two bodies start to co-rotate. Because Charon partially penetrates into Pluto, they kind of partially merge, forming something similar to a really large contact binary. Like if Erikoth was huge, they co-rotate. And Charon starts to lose some mass, kind of draining off of the back. That's what you're seeing here. That tail of green is Charon losing ice debris. That's part of its ice shell. So it loses about, depending on the simulation, between 1 to 5% of its mass to a massive icy debris disk that's scattered into the general vicinity of Pluto and Charon, and most of it remains bound to the system. So it's losing mass there. But eventually, Charon starts to separate and gets pushed away by Pluto. And the reason why this has to do with orbital dynamics a little bit. So I'm going to step through that, and I'm happy to take questions about it. So here is a series of orbital parameters that are important to think about when it comes to Pluto and Charon. So what I'm showing here on the top, time is on the x-axis, so 0 on the left would be the moment of collision, and then 60 on the right is the end of the simulation. And the y-axes correspond to distance and orbital period. And what I'm plotting here is the co-rotation radius of the system is in gold, and then the semi-major axis and periapsis of Charon are in red and cyan. And what we can note here is those initial jumps at the start of the simulation are the merger, and then the bodies start to separate between 10 and 20 hours. And then that period's a little chaotic. But then after that, we end up with this newly separated satellite that then stabilizes into a tight, low eccentricity orbit. And these peaks and troughs of the periapsis correspond to the remaining eccentricity of the orbit. But if we look at the semi-major axis, Charon's semi-major axis, or its distance from Pluto, is starting to slowly expand. So at the end of the simulation, Charon is still relatively close to Pluto, which we could observe in the previous images, but it's slowly starting to migrate outward, and it will continue to migrate outward over tens of thousands of years. So at the end of the simulation, it's only around 2 to 3 Pluto radii away, but it's not going to stay that way. If we look at Charon's eccentricity over time, it's not really that meaningful until it starts to separate from Pluto at around 10 to 20 hours. But then after that, we end up with this close, low eccentricity orbit that oscillates between 0.1 and 0.15, which is pretty close to circular. So this period here, this is the orbital stabilization. It's expected to continue to damp itself out over time as Pluto and Charon tidally interact, and Charon starts to slowly move away from Pluto to its current location, which is 16 Pluto radii away. And lastly, this is just for me. This is the angular momentum of the system normalized to the actual angular momentum of Pluto and Charon today. So like I said earlier, angular momentum of the system can be broken down into the angular momentum contained in Charon's orbit, which is in red, and the angular momentum that's contained in the spin of both Pluto and Charon, respectively, which are in gold and in pink. And if we combine all those together, we find that after Charon separates, angular momentum of the system is close to the angular momentum of Pluto and Charon today, which is how we can approximate whether or not this is a good fit. Because we're trying to match not just, did we get a satellite around Pluto, right? But is that satellite roughly A, the right size, B, the right mass, and C, is the angular momentum of the system actually what it is today? Because otherwise we're not matching Pluto and Charon. We've just made a cool satellite moon pair, which is fine, but not as accurate. One interesting thing that we found with these results is that the thermal state of Pluto really matters. So whether Pluto starts out hot, which some people have suggested that it might have done if it forms really early on in the solar system, if it forms hot, then it has an ocean prior to an impact with Charon. And if it starts cold, which would be if it forms slightly later on, then you don't have these really heat-producing radioactive isotopes that decay quickly in the early solar system. These would be stuff like aluminum-26 and what have you. If it starts cold, which might be more likely, but then difficult to form an ocean, we can easily produce Pluto and Charon. But as we start to warm things up, eventually Pluto is so hot if it has an ocean that its ice shell is weak enough that the two bodies actually merge together instead of separating. So what we found is if Pluto starts out cold, it can capture Charon. And if Pluto is warm but doesn't have an ocean quite yet, it can also capture Charon. But if Pluto had an ocean already, then it gets a little bit harder. The other interesting thing about this is that there's a lot of energy transfer between Pluto and Charon, not just during the impact, but also afterwards as they tidally interact with each other because they're so close together. So even if Pluto doesn't have an ocean at the start, it's possible that the energy of impact might provide that extra heat necessary to then produce an ocean in Pluto and Charon over time. The other thing that we found really interesting about these results is applying them to other systems, because many of the largest Kuiper Belt objects have large mass fraction satellites. 8 out of 10 of the largest Kuiper Belt objects, in point of fact, and I've put them all here. There's Pluto and Charon, of course, but there's also Eris and its moon Dysnomia. Haumea has 2 relatively large moons, Hi'iaka and Namaka. And then these other, I will not read them out to you, but all of these other systems, which are all really interesting, but about which we know a lot less, because these are all, except for Pluto and Charon, the best images we have of these bodies. So we've been able to identify the fact that they are large Kuiper Belt objects with a large mass fraction satellite, and we can develop rough estimates of the size and mass of both of them. But what we don't understand is, A, anything else about their geology, but also B, why this is the case. Why do so many large Kuiper Belt objects have a large mass fraction satellite? Well, it could be that all of these bodies have experienced something similar to Pluto and Charon and the Earth and the Moon, where there was a planetary scale collision early on in their history that then allowed them to capture their satellites as well and then stabilize over time. So to test this, we said, okay, let's pick another one of these guys. Let's pick Orcus and Vanth, which are 40% the size of Pluto and Charon. And what we found is these are 2 pretty little guys, but a similar process occurs. And though in this case, the satellite ends up extremely tidally distorted, which is why it looks like a football. But what we found is this same kiss and capture process can also feasibly reproduce smaller systems like Orcus and Vanth. And we can also reproduce systems like Eris and Dysnomia, where there's a much larger gap between the mass of Eris and the mass of its moon, Dysnomia. So this is Pluto and Charon on the left and Orcus and Vanth on the right. And I would be remiss if I did not say that the reason we're calling it kiss and capture is because of the new aspect of this process, which is that brief merge where Pluto and Charon collide and are briefly one body. That is the kiss of the kiss and capture. And then they stabilize as they separate and they form then the binary pair that we now have today. So the key points that I'd like you all to take away from this talk are, first, in the Kuiper Belt, where velocities are slow, things are colliding at much slower speeds than for the Earth-Moon system, and where the sizes are much smaller, we found that material strength really changes how Kuiper Belt objects capture their satellites. Second, we found that this kiss and capture process keeps Pluto and Charon relatively intact. There's no longer this global deformation where they lose a lot of debris. They mostly stay the same throughout the process. And kiss and capture also releases a satellite on a close, low eccentricity orbit that then stabilizes and starts to migrate outward, pushing Charon towards its current position. And these changes to the mechanics of how impact-driven satellite capture works has geologic implications for the evolution of Pluto and Charon, but also other large mass KBO binaries like Eris and Dysnomia and Orcus and Vanth, because this process imparts heat to the system, which can then reset their thermal evolution, as well as kind of lock in their structure, on top of which they then subsequently accumulate geologic activity and produce the geologic features that we see today. So with that, I will throw up my email here if you want to contact me, and I would be happy to take any questions that you have.
Good talk. Thank you. Ms. Denton, the barycenter between Pluto and Charon, does that tell you anything useful in your analysis? And also, are the two or one or both of them tidally locked now?
Oh, yes, they are tidally locked. And the thing is, actually, if we go back and look at the video, which forgive my infinite slides that I have, slides are my passion, you'll see that Charon is tidally locked immediately. So here they merge. And as Charon starts to separate, as it's doing here, it immediately becomes tidally locked to Pluto.
But what about the barycenter? Does that tell you anything about the mass of the two objects?
Well, the barycenter tells us that Pluto is more massive than Charon.
And that's all. Yeah.
Yes, and we can tell that Charon is much smaller than Pluto, and that's why the barycenter is much closer to Pluto than Charon. But in terms of how that mass is distributed, and as in like ice versus rock, that kind of stuff, that's a lot harder to determine.
But the relative densities of the two objects, does the barycenter move based on the relative densities of the two objects?
Yes.
Mm-hmm.
Though not very much, but yes, it does.
Thank you.
I have a question.
Go ahead.
James Christie, as I understand it, had a girlfriend named Charon. And that's why he searched the Greek list of names, looking for something that sounded like her name, and came up with this Charon. And I understand that the International Astronomical Association wants names like that from history. So it technically it's pronounced Charon, but
Yes.
this is Valentine's Day. So
Yes.
for the next 3.5 hours, can we not agree that it's Charon?
I will do my best. You know, once the Greek and Latin is trained into my brain, it is hard to get it out. But yes, and her name was Charlene, to be clear.
Charlene.
But yes, love is real.
Okay.
And he did love Charlene very much. So yes, that is where Charon comes from.
Okay.
And I stopped sharing just so I could see who was asking questions, but I'm happy to put slides back up if there's anything we want to look at.
Yeah, I have a question.
Go ahead.
In the early pictures, it's not quite related to the kiss and capture, but in the early pictures, you showed the brown image, brown on the image of Pluto, as well as on Charon.
Yeah.
And also white, and also some muddle between. We know that the large crater, the large white patch is largely ice, but do you have any insight as to what we think might represent the brownish colored regions?
So let me reshare my screen so that I can make sure that
Okay.
I'm getting the right thing here. But you mean this stuff, right?
Yeah, the orangey brown.
The orangey
patches.
brown stuff. Yeah.
Yes.
Yes. So
And then there's some was a mix of white and brown. But what do you think that brown stuff is?
So this image is color stretched a little bit, so it's not just visible light. They've stretched the image using other stuff, and it's meant to highlight different composition, which is why the ice in Pluto's heart is so bright white, because this is the nitrogen ice.
Okay.
The brownish red stuff is what we call tholins, which are effectively a type of hydrocarbon, actually. They're complex organic material. So it's kind of like tar, actually. And we think it forms from interactions between Pluto's surface and its thin atmosphere. So you have tholins condensing out onto the surface of Pluto at specific locations as Pluto's atmosphere stabilizes and destabilizes as it orbits the sun.
Okay.
Does that make sense? It's
Yes. Yeah,
very
absolutely.
strange, but we have tholins on Earth, and they are a similar reddish brown color.
How do you spell that word?
THOLIN.
THOLIN. Okay. Yeah, makes sense. I'm sure that that's not what we would visually see, but with some liberty of representation, so you can distinguish what different compositions are on the surface.
Absolutely.
Okay. Thank you.
No problem. Pluto's geology is fascinating to me. I think it's so neat.
Well, geology is fascinating here on Earth as well.
I completely agree.
Okay.
Yeah, I have a question regarding the simulations.
Sure.
I'm just wondering, is there any kind of observations that could be made to help narrow down, how accurate the simulations are, and what would it take to make such observations?
Pluto orbiter.
Okay. So
I'm kind of joking. I'm kind of not joking. So to be able to prove that this is what happened, we would have to be able to more accurately tie Pluto's earliest geologic history to its present day. The problem is that, like I showed in the beginning of that talk, right, there's a lot of fundamental things that we cannot constrain about the interior structure of Pluto. And if we were able to better understand whether Pluto has an ocean today and how hot it is, we would be able to better say, what was the thermal structure of Pluto like at the end of the collision process when it started to then experience the geologic activity that has built up since then. And the reason that I say it that way is because the giant impact between Pluto and Charon is effectively a geologic reset. Both bodies get completely covered in debris and new ice material. So regardless of how Pluto and Charon get captured, it's after that process that then all the geology that we see today would have happened. So if we could better understand the actual makeup of Pluto and Charon's interior, we would be better able to answer these questions. But to do that, you would have to orbit Pluto. And the reason we would need to orbit Pluto is because to get the kind of geophysical data about the interior structure of Pluto, you would need something like gravity data, which requires multiple flybys to slowly build up over time. Does that make sense?
Yeah.
yes, it does.
Mhm.
So, John, that's like the Apollo spacecraft figured out that the moons has gravitational odd places. So the thing going around Pluto, if the orbit doesn't behave the way you expect, then you've got more mass here than there, right?
Exactly. The Apollo program was what discovered the mass cons in the lunar impact basins. And that would be a great way to be able to test whether Sputnik Planitia is the same thing. Because that's what we think Sputnik Planitia, the heart, actually is a giant mass con basin like the mass con basins on the moon that were discovered from Apollo.
Mhm. Okay.
Are there any hypotheses to how long ago Charon was created?
It would have been quite early on. So large things simply are not colliding with each other very often today, which is good for us, right? That's great. We think that the time in which planetary scale collisions, which would be anything in which when the two bodies are comparable in size, we call that a planetary scale collision because it's two planets hitting each other, right? So the Earth-Moon collision would be in this regime. We think both the Earth-Moon collision and the Pluto-Charon collision would have happened at around the same time because that's when the solar system was still kind of settling into the solar system we now have today. And that last stage of planet building in which large bodies are hitting each other is possible because the giant planets were still settling into their orbits. And the migration of Jupiter in particular was what could perturb the orbits of smaller bodies and allow them to be on collision courses. So all of that would have happened within tens of millions of years after solar system formation. So say 60 million years after solar system formation, which would in turn mean, over 3.5 billion years ago is when this is most likely to have happened. It's obviously very difficult to say for sure. With the Earth and the Moon, we can be a lot more precise because we can date the rocks of the Moon and the Earth relative to asteroids, which are much closer to the age of the actual solar system, and get an estimate of how old they are. With Pluto and Charon, we don't have that information yet.
Thank you.
Yeah.
Ms. Denton, are you studying contact binaries also?
I think they're neat. So I don't personally study them, but I work with a lot of people that do. And contact binaries are, in the case of Arakoth in the Kuiper Belt, and the mini contact binaries in the asteroid belt and the Jupiter Trojans are thought to originate from a collision where a very, very slow collision where it's so slow that the two bodies, instead of destroying each other or merging, just get stuck.
Thank you.
They're really neat. I think they're fun.
Instead of kiss and capture, they're kiss and I just lost my train of thought. Sorry.
Nice.
Kiss and embrace. That's what I was going to say.
There you go. That's
Kiss and hug. Okay. Excellent talk.
yeah. Thanks for having me.
Thank you.
Excellent.
Excellent. Yes.
Thank
excellent.
you.
Well, if you have any other Pluto questions, feel free to email me.
Are
Oh,
we allowed
actually,
to ask you the question? Do you think it was a real planet or a dwarf planet, right? When I grew up as a kid, it was the 9th planet.
When I grew up as a kid, it was the
whole observatory is all about having Pluto as a planet. I'm just curious where you weigh in your observation.
Well, I'm happy that Pluto still gets so much love because it used to be a planet and now it's not. To me, I think it is the largest object in the Kuiper Belt. It's not the most massive. Thanks, Eris, for that. But it is important not just in the scale of the solar system, but also important in the scale of human exploration of the solar system. So that's where I think Pluto being a planet is really important. To me, I'm happy either way, right? Dwarf planets are still neat, and I understand kind of why we had to introduce dwarf planets, even if I don't necessarily agree with it. But to me, one of the things that's been kind of developing in the last couple of years is the idea of a definition of what a planet is based on what kind of geology it's capable of. So like a geologic-based definition of a planet. And by that definition, Pluto is incredibly geologically active. It generates its own geology. And to me, that makes it a planet. But that's a whole other idea for how to define a planet. And as scientists, we are arguing about it basically all the time.
Thank you.
Of course. There were a couple of raised hands I saw.
That was it. Me hitting the wrong emoji.
That's okay.
I think if you call it a dwarf planet, it's a planet.
There you go.
It's just a different kind of planet.
I'm right there with you.
I do quite a bit of outreach with people, and I very commonly get the question, is Pluto a planet? And my standard answer for people is, you tell me what your definition of a planet is,
Exactly.
and then I'll tell you if Pluto is a planet. And most of the time, their definitions would include all of the asteroids and all of the comets. They'll say something like, it's something that goes around the sun. And I'm like, well, then we got millions of planets.
Yeah.
And, if they can give me a good definition of a planet that excludes Pluto, then I'll agree with that. But most of their definitions are pretty poor.
Yeah. I think Pluto is such an interesting case study in like how we divide and categorize things as people to make the solar system more understandable for ourselves. And there's always going to be a little bit of disagreement as to how all of it works. So to me, Pluto is a planet, but as long as we all agree it's a cool thing to study, I'm happy.
Well, perhaps we have more than one Pluto because there are a number of other objects that are larger than Pluto, but have not garnered the attention of being called a planet. They've just been sort of semi-ignored. So perhaps those other objects were actually a little bit bigger than Pluto, would be equally interesting, if not more so, and probably bear much of the same phenomena that you described.
Oh, yes. There's been suggestions. People have tried to look at the other large Kuiper Belt objects that I showed you, particularly Eris and Haumea and Makemake, which are the next largest ones, with
Mhm.
the space telescopes, including Hubble, but also JWST, the new one, and found it looks like some of them might potentially be geologically active. And the reason they think that is because there's these kinds of bursts of volatile gases. It looks like there's kind of bursts of methane and ammonia, which could be from like some form of volcanism. But it's very difficult to prove or disprove because, again, we're just looking at very small objects with a space telescope. So I certainly agree that all of these large Kuiper Belt objects could be just as geologically active as Pluto. It's just a matter of being able to actually take a closer look and see that for ourselves.
You probably need some sort of a critical mass size. And once you get beyond a certain critical mass size, you will inherently get various geologic phenomena through the body. But
Yep.
when you go below that critical mass size, it just becomes a rock and stays a rock.
Yeah, sorry to most asteroids, but they are rocks to me.
Yeah.
Very nice rocks, to be clear.
Yeah.
All right. Well, thank you so much, Dr. Denton. It was a pleasure and an honor for you to speak with us tonight. Very much enjoyed your presentation. It looks like everybody else did too. So thank you so much for joining us. You are more than welcome to still hang out if you want to listen in on our general meeting. We're basically going to probably take a 5-minute break and then we'll restart, but you are more than welcome to join us if you would like. If not, again, thank you so much and happy Valentine's Day and good luck with your future research and please stay in touch. We'd love to hear, any other exciting projects that you're working on or your team's working on. So thank you again.
Absolutely. It was wonderful to chat with you all. If you have any other questions, don't hesitate to email me. I'm always happy to talk about Pluto with like-minded folks.
Okay.
Thank
you.
you.
Thank
All right.
you.
Thank
Great talk.
you. Thank you so much.
Thank you.
Sounds good.
What?
All right, welcome back, everybody. And to those of you who are joining us on YouTube, thank you very much for joining us tonight. If you haven't already, please like and subscribe to our YouTube channel. We are reaching out for some educational videos on astronomy, also some intros to telescopes, and lots of advice from a lot of our members here at the 3AP in Pittsburgh. So thank you again for joining us tonight. All right, and welcome members. I hope you guys enjoyed that wonderful presentation we just had. And we're gonna go ahead and get started. So again, this is our February general business meeting. And we're gonna go ahead and get started with minutes from our last meeting from January 10th, 2025. Rich, are you prepared to read over the meeting minutes from January?
Yes.
Okay, I'll let you take that away then.
The Friday, January 10th, 2025 business meeting was online only, Google Meet, and live streamed to YouTube for public viewing. 39 members attended. Meeting began at 7:30 with a presentation by John Wenskevich, 9 Years of Planet 9. The general business portion of the meeting was called to order by President Kristen Crawford at 8:50 p.m. The minutes of the last meeting were read and unanimously approved. Motion to accept by Eric Fisher, seconded by John Diller. John Holtz gave his look at that presentation. Some of the highlights included the Mars opposition and Mars lining up with Pollux and Castor, conjunction of the Venus and the Moon, and the Venus opposition on February 16th. Board reports. President Kristen Crawford has attended several observatory meetings in the past month and thanked everyone for their help with the holiday party. She's planning on calling a policy and procedures committee meeting. Many of the policies listed on the club website are old and need to be updated. Vice President John Wenskevich has people who have expressed interest in presenting for one of the spring meetings, but no one has officially committed. He also threatened that if people don't commit, we will hear more from him. Recording Secretary Rich Dullish, nothing new from the Recording Secretary office, but I did mention the hands-on telescope seminar that I held at Mingo Observatory. Dave Rager was not present. Terry Mealy, nothing to report. End of year and fourth quarter reports will be released soon. IT chair was not present. Guide star Joyce Osborne Fisher. Joyce requested articles from the members about their observatories and or other equipment, any customizations you've made or other things that other members might be interested in. Gail Reger, nothing to report. New members to the club were listed and the motion to accept passed unanimously. Motion to accept by Frank Paston and seconded by Phil Breidenbach. Member total at the time of the meeting was 496 members. Wagman report. Director Eric Fisher reported that the directors had a meeting with Allegheny County deputy directors and park personnel. The county is agreeable to put in a parking lot on the east side of the hill with an access road. Contractors are coming out to bid on the floor of the Brashear room, but they still need to determine whether it will be a full or partial replacement. The Starlink system is installed and they are looking to pave the lane behind the observatory to help solve the water seepage problems in the north corner of the building. They also want to add some new monitors for member AP slideshows and an EAA setup similar to what Mingo has. Finally, Eric reminded everyone that Ken Coles would be having a beginner telescope class before the final star part. Boy, he's that old. Sorry, that was a carryover. Ignore that last one. Mingo report. Director Brian Crawford reported that Shelter 10 has been reserved for a members' picnic celebrating the 20th anniversary of Mingo. The first committee meeting was held along with the vote of confidence for the Mingo leadership. Brian, Mike Metney, and Heather Panic all received positive votes and will retain their positions. Plans were finalized for the planetarium remodel, including carpeting and hookups for cameras to ease recording of presentations and streaming to the 10-inch anteroom. Old business, the holiday party was a success with 2 pans of extra food being donated to a veteran shelter. The 100th anniversary club is still coming up, and Kristen asked members for ideas on ways to celebrate. And a reminder was posted to please renew your membership before the grace period ends on January 31st. New business, 3AP will have a booth at NEAF this year. 6 members will be heading up to staff the booth and promote the club. Club calendar has been updated with the observatory star parties and offsite events. We had a quaffing at Max's Allegheny Tavern January 31st. And motion to adjourn at 9:48 by Eric Fisher, seconded by Patrick Rigger, unanimously accepted.
All righty. Thank you, Rich. Can I get a motion to accept the January 10th, 2025 general meeting minutes? All right. Tom, I believe I saw a thumbs up from you. Okay. All right. May I have a second, please? Phil? All right. All those in favor, you can do thumbs up or say aye.
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 All right. Any objections, please say nay. Any abstains? All right. Motion passes. Thank you very much, everybody. All right. Let's go ahead and move on. So next we have Look at That by John Holtz. John, I do have your PowerPoint if you want me to present it, or if you want to, you can go ahead and present. What would you prefer?
Go ahead and present it. No.
Oh, yep, I can do that.
It's coming.
It's a coming. All right, it should be displaying here.
Yep. Go ahead to the next slide, please, Kristen.
Absolutely.
And we'll get into the standard list. Gee, I just realized I made a mistake on March 14th, but don't worry about that. Anyways, a typical list of upcoming events with the planets and moon. In case you haven't seen Venus, it's pretty bright. It's at its brightest on the 16th. Antares and the moon will be close on the morning of February 21st. Saturn and Mercury will be close to each other on February 24th, but you may need binoculars to see those. And I'll hopefully touch on that in a moment. And some of the best events seem to happen right here in a row at the end of the month. February 28th, the very thin crescent moon, just 22 hours after new, will be near Saturn and Mercury. On March 1st, the next evening, the moon and Venus will be close to each other. What's interesting is this is the last evening conjunction because Venus is going to rapidly disappear and then become a morning object by the time the moon and Venus conjunction occurs at the end of the month. So take a look at March 1st if it's clear. Next slide, please, Kristen. And then on March 8th, Mercury is at greatest elongation, should be much easier to see even with without binoculars. And this happens to be the best evening apparition of Mercury for this year. The Mars and Moon return to each other also on same evening, March 8th. And March 11th, 12th, that night, the Moon is approaching Regulus throughout the night. March 12th, Saturn is at conjunction with the Sun. And that's why I was mentioning that the Mercury-Venus conjunction on February 24th, just a couple weeks before solar conjunction. That's going to make it a challenging observation, I'm sure. And on March 14th at 3 o'clock in the morning, that's the maximum, that's the time of the middle of totality for the total lunar eclipse. And when we get to the observatory reports, I'll be sure to ask the directors if we're having a public star party at 3 o'clock in the morning. Eclipse watchers. If you go to the next slide, please, Kristen, here's the details of the upcoming eclipse. Basically, once the moon starts to enter the umbra at 1:09 a.m., that's when the eclipse becomes more readily visible. Totality lasts between 2:26 a.m. and total eclipse begin, mid-eclipse, there's the end of the eclipse at 3:32 a.m. So just over an hour-long total eclipse. And then the partial eclipse ends at 4:48 a.m.
Hey, John, any occultations during totality?
That's a good question. I'm not sure. Well, let's see. The sun will be near. So what's the opposite of Pisces? Over in Virgo.
Yeah.
So not necessarily a star-rich region of sky, but I'll make a note to look up to see if there are any occultations during the eclipse.
And be aware that someone will ask us why we didn't schedule this for a better time.
That's true. Why not 3 p.m. in the afternoon? All right. Next slide, please, Kristen. And the next slide for the members' photos from the past month. I didn't have a lot of time to gather these, so I only have a few. Eric Bauer captured two images. I'm sorry, he captured 3 images of the Mars occultation on January 13th and put them together in 2 different formats. In this format, he positioned all the photos of the moon was at the same position, and you can see over the course of roughly 45 minutes how the moon or how Mars is getting closer to the moon. The closest image of Mars, a little dot there just off the limb at the 7 o'clock position. That's 6 minutes before the actual occultation. Yes, and then the next slide, he aligned the 3 photos so that Mars was in the same position, and now you can see how the moon is approaching Mars over that 45 minutes or so. And Eric Bauer, I don't know if you're still on. If you are, if you want to mention any details about this process, feel free to come on.
Sure. It's done with a point and shoot camera. And I think I had it, that was 16x zoom and a 2x electronic. So it's a 32x. I'd have to look up what the shutter speeds and ISO were. I stacked them up in Photoshop Elements, just roughly. It wasn't too hard. It wasn't too hard with Mars, because basically it was just a, handful of pixels.
Right. Well, so it's quite amazing that, and this was handheld, I assume.
No, this was on a tripod.
Okay. Yeah, it's still amazing though that Mars shows up, even though it was so close to the moon.
Mhm.
This was, I think this was the day of the full moon. I think the reappearance of Mars was either 4 hours or 6 hours after full moon. So
Yeah, I didn't wait for that. Yeah, this was trying to remember, but about 9:30 in the evening.
yes,
How much time is between those shots? About
Let
6 minutes.
no, let me check. I got to bring up photo.
yeah.
In,
I remember your post said that the last photo was taken about 6 minutes before the occultation, but I don't think you mentioned when the first photo, how
okay.
much time before.
Yeah, Mars occultation.
And actually, while you're looking that up, let's
Yeah.
just talk about observations. If anyone else saw the occultation, I was watching through binoculars, 10 by 50 binoculars, sitting out there in my lounge chair. I'm sure the neighbors were wondering, what's this guy doing sitting out here? I don't remember if it was 20 degrees or 15 degrees outside, but it's a bit chilly. The disappearance, I couldn't tell definitively when Mars disappeared versus just getting lost in the glare. But the reappearance, even though it was just a few hours after full moon, I could detect a little bit of a terminator in my binoculars, and the reappearance of Mars, based on the calculations, I saw the reappearance to within 1 second of when it was supposed to reappear. So I thought that was pretty impressive.
Yeah, Phil, that was about a 15-minute span. 14 minutes. The furthest away was at 8:53 p.m. and the closest was at 9:07.
Wow.
So about 14, 15-minute span.
One of the things that I found really fascinating about watching that was how it almost seemed as if the speed of the moon approaching it was increasing.
Right.
Just because as it got closer to the planet, the motion was more obvious.
Yes.
Well, that's
It
because of the
almost was like it sped up, and the same thing happened with the reoccurrence too, or the reappearance also.
Right. That's because of the gravitational attraction between Mars and Moon got real close.
I never thought of that.
You learn something new every day, I'll tell you.
Can I quote you on that?
Phil Breidenbach, Jody Farr, and I are sorry that the rest of you weren't at the Brashear telescope, because through the Brashear, you forgot that you were cold. That's how impressive it was.
Yeah.
One thing I remember, I noted it in my post. The conditions were excellent.
Yes.
I had a better view of Mars at 14.7 arc seconds versus 24 arc seconds 3 years ago.
Right. Yeah, the seeing was amazing. And the glare of the moon did not wash out the features on Mars that much, even when it was close.
No, you could still see the dark features as it touched the limb.
Mm-hmm.
All right, Kristen, if you would, let's go to the next slide. Photo from Tom McLaughlin of the Moon, Venus conjunction up on the top and Saturn down at the 5:30 position. And regarding that, just want to mention that I forget now what day that was. Might have been February 1st of the Moon and Venus conjunction. I used the moon to locate Venus in the daytime, and it was, once you know where to look, Venus is actually pretty easy to see in the daytime. And then again, I don't have my notes with me, but whenever the moon and Jupiter were at conjunction, I was able to see Jupiter in binoculars during the daytime, but there's no way I would have been able to see Jupiter naked eye. It was just too faint. And then a few days later, for the Mars and Moon conjunction, I tried to find Mars in binoculars, but I could not see it. It was at about minus 0.8 magnitude in brightness, so it's probably too faint to see at the daytime, even with binoculars. Does anyone else have some observations they'd like to?
I want to say that people were asking me about Venus as approximate to the moon, and they're guessing it was Jupiter because they couldn't imagine, or it didn't occur to them that Venus could be so bright. They thought it must be a much bigger planet.
Yes, very good. Anyone else have any observations they'd like to mention?
Yeah, I actually did video of the moon and Mars, and it exposed the moon really great. And Mars is just a tiny, insignificant speck on the screen, so it didn't come out great. Although the moon picture, it was a very clear night. Like sky conditions were really sharp, so the moon came out great.
Yeah, that's a very difficult. I don't know how you'd be able to do it to get the proper or better exposure on each item.
I'll have to share the picture that I got of it. It's a thing.
Right. All right, that's all I have, Kristen. So it's back to you.
All righty. Thank you so much, John. Much appreciated. Great. We'll switch back over here. Let's see here. All right, so it should be popping up here in a second. All righty. Okay, so moving on here, let's go ahead and go over some officer reports. John, do you have anything to report? Do we have a speaker lined up for March's general meeting?
So about 20 minutes before our meeting started, I got a message from the speaker who I thought was going to be presenting in March, but declined. Wanted to finish his dissertation or something not so important. So that means that March is still open, as is April and May. I'm going to start doing a bit more outreach and see if I can find a replacement. But if you want to make my life a little bit easier and present on Pi Day, hopefully about something other than Pi, then definitely let me know.
All righty. Sounds good. Do you have a preference on a deadline so everybody knows?
Anytime in the next couple of days. I'm planning on sending some messages over the weekend, but if anybody wants to reach out before that point, that would work out great.
Okay, sounds good. Thank you, John. All right, Rich, did you have anything to report for recording secretary?
No, nothing for recording secretary, nothing new for offsite star parties either.
Okay. Did you by chance have anything new for VA?
No, nothing new for VA either.
Okay. Just have they reached out recently for any, I know it's kind of cold outside. Did they want to plan something once it starts like warming up? Have they talked to you about that?
They don't ask me to plan anything. Basically, I go to them. So yeah, once probably in March, maybe we'll try to get it. With the VA roles for volunteers, if you're not a registered volunteer, basically you can only go out about 3 times per year. Otherwise, they don't want you going out more than that for whatever reason. I'm sure it's valid for them.
Yeah, I see your point there. I see your point. All right, thank you for the update.
Mhm.
All right, Dave, I see you are on. Do you have any updates for corresponding secretary?
Sure, just a quick one. So I've been able to reduce the number of emails coming into the corresponding secretary inbox. It was just getting flooded with the typical listserv communication, and I wanted to try to filter that down to just get the folks coming in through the website, and it was just a lot of noise there. So I've been able to do that, but we've been getting some interesting inquiries. Some folks are asking about the loaner program. There's some folks that are asking about, the planet alignment here coming up on the 28th. And then there's some membership questions, things like that. There's also been a few that I've forwarded, to a couple of folks on the executive committee. Had one with a concern on light pollution, which I forwarded to Diane. And she responded to that. And it's nice to be able to have resources for folks, that we're able to help and answer their questions, as well as had some inquiries on scout visits, things like that, and actually had one on asking about the roll-off observatory design. So I've been responding to some of these here even this evening, just going back through, and it's just interesting to see that people are going to the website, they are using the links, and they're engaging. So it's just nice to be able to support them.
Okay, great. Thank you for the update, and thank you for responding to the folks in a timely manner. I'm sure they really appreciate it, and the more information that we can give everybody, the better, for the club and also for the public that we're serving. So thank you very much. Yep. And thank you to those who are assisting Dave in answering those emails as well too. Very much appreciated. All right. Patrick, I know you were online. Gail, did you, if she is online, did you have anything you needed to report?
Oops.
Gail's right here, but she's still getting over the flu. She just wants to remind people to use our address when sending correspondence to her and not use the PO box.
I could somewhat hear what he was saying. I don't know if anybody else had difficulty. It sounded like. Okay.
Yes, if I could add it, we had 2 members renewing their dues who sent it to the PO box. So we'll probably put something in the guide star to try to remember or remind people that any correspondence with the membership secretary should or about their membership should go directly to the membership secretary.
Okay, yeah, and I believe their address, at least Gail and Patrick's address, is on the 3AP website for the membership secretary, but we'll double check that as well too, just to make sure that's squared away. And it should be also on the welcome letter. But thank you, John, for translating that. Much appreciated. All right, Terry Mealy, are you on tonight? Okay, I didn't think I saw him. All right, Michael Scovrin, are you on? Okay, I didn't think he was on either. All right, I know Miss Joyce is on. So Miss Joyce, do you have anything for Guide Star?
Yes. Well, first, as I have behind me Eric's homemade Saturn V and gantry model inspiring me. I just thought an inducement for people to write articles could be that in addition to the membership, the Guide Star also goes out to organizations and institutions and individuals in the astronomical community locally, such as Moonshot Museum, the Allegheny Observatory, the Buell Science Center, and the individuals escape me. So you'll get a wide audience. And do not be afraid if you feel like you're not a writer. Just stream of consciousness. Just put down your thoughts, put them in a bullet form if you want, or just however you think them, because we will edit and format it to make a nice article for our magazine, as it were. So please, whatever whatever astronomically interests you, in addition to your observatories, remember. Okay, that's all for me.
All righty. Thank you, Joyce. All right, so I believe on this next slide here, we did get some new members since our January meeting. So I do not know if any of these members are on tonight. I did see one of these new members had posted something on Discord. I did see that name show up. But is anybody on tonight that's listed on the new members list? If you're here, don't be shy. All right, I guess we're either too shy or we haven't come on just yet. I mean, I understand it is Valentine's Day, so you know. All right. So before we go any further, so with the members that are listed on my screen, so this is from January 11th, 2025 to February 14th, 2025. May I get a motion to accept?
So moved. I'm sorry I didn't let you finish your sentence.
No, you did not.
I am sorry. Mea culpa. I am sorry. I was excited.
Oh, that's okay, Joyce. I know you're excited. It's okay. All right. May I get a motion to accept the new members that are listed on the screen here?
Okay, Joyce,
John
go for it.
I think we got it. All right. So I'll go ahead and let Joyce take the first motion because she was so shy and everybody else kind of jumped. All right. So may I get a second, please?
John Holt, second.
Okay, John. All right. All those in favor, thumbs up, say yeah.
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 Yep.
Yeah.
Oh, there you go.
Any objections? Any abstains?
Dan, you have a hand raised. Is that for an objection or abstain?
I think that was it was an accept.
Yeah, I was trying to
Okay,
thumbs up there. Sorry about that.
just making sure.
All right, so motion passes to accept our new members. So I believe the total members that I counted, these are including the new ones here. it for the club is 339. So if you guys recall, for our January meeting, we were at 496. So now we're back down to 339. So I do know that periodically with the club, we do go through that like up and down wave effect when it comes to like the membership renewals. And we're going to talk a little bit about that further into this meeting. So just to kind of keep in mind, so difference wise, we're looking at a little over 150 like members that have not either renewed or come back. So, you know, again, we're just going to like briefly talk about that, but just keep that number in mind as we're going further through. Okay. All righty. Okay, so observatory reports. Wagman, I know Eric is on. Mike, you're on. I didn't see Jody on tonight, but I'll let you two hash it out on who wants to give the Wagman news.
Okay, drum roll, please. Somebody do a drum roll for me. Wagman, as you might have seen, has a combination lock on the gate. Yeah.
That's a
Bada
drum roll.
bing, bada bing.
After years of complaining, 10 to 12 years of complaining, we've got a combination lock back on the gate. And I got a slightly longer shank so that you don't have to contort yourself like a pretzel to read the numbers. It's very easy to open. Very quickly, other items. I've gotten three carpentry companies have come up to give me an estimate on repairing the floor. We do not have to replace the whole wooden floor in the brashear room, just localized repairs. And I've not gotten any estimates yet. I've gotten three guys show up. About a week or so ago, Jody Fard noticed moisture inside the brashear pier. If you remember, the brashear pier has these little glass windows, doors, I guess you'd call them. So we put in a new heating element on the bottom of the pier, and we used the Bulbinator 5000. Now, I'm not going to say much more about that, except that it'll be in the guide star. We're going to be having our first work party probably in March, whenever the weather breaks 60 degrees or better, dry day. Wagman has not had a work party in decades, and we're going to have one. We're going to tear out the rugs. We're going to protect the brashear telescope during the carpentry work. We're going to do a bunch of stuff, so that'll be announced. Let's see if those are the major things I have. Well, final comment, then I'll let Phil and Mike talk. As I get to see this building more closely and understand it, the guys that built the brashear wing did a fabulous job, and the brashear telescope got it set up. The workmanship, the detail, Phil Breidenbach, Flax Stifel, Wade Barb and Dave Hoogie, Ken Kobus, they did fabulous work on this wing, the building and the telescope piers, and I'm going to congratulate them in the March Guide Star. We're lucky to have them. This wing is overbuilt. It's very well done. And by the way, I see Bob Fryman in the group today. He helped me a lot, especially crawling down on the floor to access things, because I can't do that anymore. And with that, I'll leave it up to Phil and Mike and Bob if you have any other follow-up comments or questions about the Wagman work.
I have nothing.
Okay.
I have nothing. Go ahead, Bob.
Yeah, back to the combination lock on the main gate at Wagman. The old lock had a chain to prevent you from walking off with the lock. We don't have that set up with the new combination lock. So just want everybody to be aware of that, because I have no idea how to get that chain off, or even how to remove the old lock from the attached chain.
We're going to put a bypass chain and then just take a bolt cutter and cut the old lock off if we have to. But it's something to be done. We have to have another chain that's attached to the hasp. So
yeah, I'm assuming the old key locks, Bill Yorkshire just changed the tumbler setting with the key instead of replacing the actual physical lock, because there was really no way to do that.
Yeah, it's just much easier now. And of course, remember when you close that lock, you set all the digits to 0. Otherwise, the next guy is going to see our gate numbers neatly displayed there. So,
yeah, even if you dummy lock it, set it to 0.
Right.
Hey,
All
Harry.
righty. Whoop.
Harry,
Yes.
you're gonna pave that the driveway to the north side of the building?
Well, paving in the sense we're going to lay down more number 2B limestone. We're not going to put concrete or asphalt. You don't do that because that just generates heat waves around the building. But yeah, it's time for us to get another layer of limestone on the roadway to the observatory.
The other thing is, I don't know how, if that should be tapered away from the building just to help keep more water from going in.
That could be, yeah. Yeah. Remind me, bring that up the next time we talk.
Yeah, Frank, we did notice there is a bit of a rise sloping towards the building, and that was part of the wetness problem. So
Yeah.
you're right. We do need to get that when we get the rocks.
Anything else about Wagman? We're getting there, folks. And we're making up for about 10 years of neglect, so it's going to take a little time. Okay, Kristen, that's all I got.
Okay. I know, guys, lots of projects, but you guys are doing a fantastic job, and we are very grateful for like a wonderful team for sure. So thank you guys so much, and thank you for keeping us well informed as to what's been going on. It's nice to know what's been going on, and also, you know, the more we talk about it, the more we can help each other out as well too. So thank you very much for keeping us in the loop. Alrighty, so moving on, Mingo, I know Brian's on. Brian, do you want to give us an update on Mingo?
Sure. Last Saturday, we had our first work party of the year. It was for our first work party of many to start our planetarium remodel. We got the planetarium emptied out. We got all the wiring disconnected. The planetarium station moved over but not wired up to the other corner. Michael Scovern was there, took down about probably 2-3 pages of notes on our tech setup, and we're waiting for him to get back on the hardware that we need to implement that. Once everyone filtered out, John Stump, Sean Mattoon, and we went up to Home Depot, secured some supplies to start on the shelving, and then wrapped up for the day. But thank you for everyone who did come out and help get the planetarium cleared out, all the tables and chairs, garbage and displays. Probably the next 2 work parties are going to be much smaller. We don't need a large group to run wires up in the attic and hang shelves, but I'll keep everyone posted on that. Beyond that, there's nothing really new at the observatory. To answer John Holtz's question, Mingo is not planning on having a public star party for the lunar eclipse. Personally, I will, if it's clear, I'm going to try to live stream it. Now, whether that's going to be on the club channel for members in the public or my personal channel, that's to be determined on the weather and the interest of how many people want to go up to Mingo for that. I gather if it's clear, there's probably going to be half the club there because all it's been is cloudy lately. The only other thing that's not necessarily Mingo related, it's more of a NEAF update. Many, if not everyone, knows that the 3AP will be represented at NEAF. There is 6 members, myself included, that will be up there representing the club. We are officially on the website as a quote unquote vendor, even though we're not a vendor, we're a club. So if you want to, see the 3AP out in the wild beyond our own website, you can go to the NEAF's website and see us listed there. But the important thing is, I posted this on the Discord. I think Mike Miller is going to be reaching out to Joyce to get it in the next Guide Star. We're looking for your best astronomy, astrophotography photo. And this will be used for any promotional materials, either current or in the future, that the club may use. Specifically for the project that we're using it for NEAF is we're going to be ordering postcards, and we want to feature our members' best astrophotography photos on the front of the postcard to hand out for free as little giveaways. So I haven't received any as of yet, but if you want to submit a photo please send it over to the Mingo director email, or just send me a message on Discord, my personal email. Just make sure you get that over, because we do have a hard deadline to get these ordered. We have to have all the entries in by March 1st. With that, we're working out the design details for the back of the postcard where you'd write on it. Of course, it's going to have our website on it. On the back side, it's also going to have our logo. And then if we can squeeze it, we're also going to have the target name, and then captured by 3AP member Eric Fisher, or whoever captured it. But on the front where the picture is, we won't have any other 3AP logos, so it'll just be your picture right up front on display. So please get those into me if that's something that interests you.
Hey, Brian.
Yes.
Brian, this is Eric Fisher. Would you be able to hang on to those old planetarium chairs a little while longer until we have our first work party done?
Oh, I've already moved them out to the front door there, staging to come up your way, along with the chair that Dan Peden we're holding for. But no, yeah, we can hang on to them a little bit. Do you have a time frame? Is this like mid-star party season, or
No, just until maybe mid to late March. That's all.
Oh yeah, that's not a problem.
Okay.
Yep.
Because we're doing a lot of work, and I just want to keep as empty as possible.
Yeah, that's not a problem.
Thank you.
Yep. And that's everything that I have. Thank you.
All right. Thank you, Brian. Much appreciated. And thank you to everybody up in Mingo for doing a fantastic job with the remodeling and also getting things prepared for the Stars Party season. So lots of good teams going this year. I think it's going to be a great season for sure. All righty. So we're going to go ahead and move on here. So old and new business. So Brian already kind of went over NEAF for April. I did discuss this last meeting. So, again, he just went over this. Again, the 3EP events are now on the club calendar. So if you guys are marking yourselves down for like vacations to the beach for the summer, or, get-togethers with your buddies, take a chance and look at the club calendar to see if there's any big events going on. And again, one important event that we have in August is the anniversary at Mingo. Also for old business was the club memberships renewals were due. So I believe the end of January 31st was whenever that expiration was going to go into effect on February 1st. So for those members that were a part of Discord, list server, if they did not renew, they were no longer able to get access to Discord or the list server. So if you guys have anybody reach out to you saying that they are unable to get the guide star, or they're not hearing anything on the list server or Discord, they need to check with Gail. They're more than welcome to email me to check on their membership, because most likely they did not renew. So again, just getting the word out there. For new business. So there's been a couple of conversations that we've been having, not saying that we put anything set in stone at this point. So I don't want anybody to think that this is for sure something that's going to happen. But one thing that we were kind of experimenting with, also talking about, was doing an auto renewal for club memberships. So basically with our conversations, we can see some pros and some cons for that. Pros would be you would no longer have to worry about renewing for your club membership. Like if you wanted to set it for an auto renewal, for every year, it's something that we are looking at. Obviously the cons are, if you're setting that with a credit card, if your credit card expires, or, if you no longer want to be in the club, or, a member becomes deceased, anything like that. So there's some pros and cons, but it is something that we are kind of just discussing at this point. But like I said, nothing is set in stone. One thing that gets brought up every year is seeing the memberships go up and down. And we're kind of sometimes we're sure that where we see those membership spikes is whenever there's really big events going on, whenever we have, of course, the solar eclipse that just occurred this past year, or, the comet or meteor showers. That's where the driving spikes for our memberships come in, because people want the access to the observatory grounds. The one thing that we're trying to see if we can level out is to get enough of that interest to keep the membership. So after that big event occurs, we're trying to see where we could level at to gain the interest for them to, want to stay within the club. So that's where we're kind of at, still experimenting with. One thing that we had talked about, and I think may have done several years prior, was doing like a survey, seeing, if there's anything else more that the club can do to keep those interests a little bit higher. So these are all things that, we can think about. Is there some things that are missing, or are there things that we used to maybe do in the past that kept interest with the club that we're not doing right now? So just things to keep in mind. But regardless, the auto renewal is something that we were talking on and off about. Again, please don't think that this is something we're going to go right into for next year, but it is something that we're discussing just to see if it could be an option. Excuse me. Another thing that we also are talking about is doing a storefront for the 3AP. So a lot of members and also non-members, so personnel that come to our star parties, they see our 3AP merch. So some of us have our 3AP hats, some of us have our t-shirts, and members, non-members, they ask, where can we get these t-shirts? Where can we get these hats? So one of the things that we've been looking into is, can we start a storefront with or for the 3APs where people can actually purchase, members can purchase items that, are representing the 3AP. One of the snafus that we keep running into is basically due to our nonprofit status is whether or not we can actually sell items. Can we do it as a fundraiser? Can we do it as you go online, you purchase a medium t-shirt that has our 3AP logo? Does that put us in trouble with our nonprofit status? So these are the things that we've been slowly and trying to gradually look into. The problem is there's a lot of uncertainty as to what we're allowed to and what we're not allowed to do. So I decided to bring this up during the general meeting because I don't know if anybody has a little bit of expertise with with accounting or with tax representation, or if you guys know anybody that could maybe help give some advice. Right now we do have a organization called Pano that we are listed with that can answer some of these questions, but it's kind of one of those things where they can give you a general idea of what XYZ means, but you're trying to get those X1 and X2 questions answered. And right now we're kind of hitting sometimes a little bit of a brick wall with. So if anybody knows anybody that could help with some of these questions or see about, potentially even doing something small and then gradually, see if we'll go bigger, not sure. But I do know that other than the holiday party where sometimes we'll just do a bulk ordering and, give that for the members. But if it's something that could potentially be offered all year round, or like I said, for anybody that is not a member of the club, if they just want to represent because they came to a star party and they really liked us and they're like, yeah, we'll definitely advertise Swagman for you, or, Mingo. It's just options. So these were just a couple of things I wanted to bring up. Definitely looking for some insight. Rich, you had your hand up?
No, that was an accident. Sorry.
Oh, okay. No problem. John, did you have your hand up?
Yeah, I know nonprofits can have storefronts. You can sell T-shirts and merchandise that is completely well within tax code. You just have to make sure you track your um, expenses and revenue properly and file the proper documents under, I think it's the 990T, I want to say. So it's 100% something we can do. The only thing we have to look into, and I don't know much about Pennsylvania state law on this, but we do would have to look into liability of the product, and if Pennsylvania requires anything specific on that. I can try and reach out to some people that I know that have done a lot of work with 501c3 groups. I don't know if they have specific accounting work, but they might be able to answer some more questions.
Okay, yeah, that would be great. Two of my coworkers, they work with humane societies, and their presidents were supposed to get back to me. I actually talked to them 2 weeks ago, and I actually forgot about that. But yeah, that's what I was saying. Like it can be done. It's just trying to find those little back alleys that, if a question comes up later, or if there's a form that we're supposed to file, some those are the things that we're trying to avoid, like not, at least making sure we get those done. All right, Rich, I think you had your hand up, and then Brian had your hand up.
Yeah, I did attend that conference for Pano last week, and like you said, I mean, it was just a high level overview of all things nonprofit, and I did specifically ask about T-shirts and other swag, and what John said is correct. All nonprofits do make money. Even hospitals and churches, they have income coming in, so we are allowed to sell that, but it's declared as unrelated business income, I think they call it. So it would be, we would have to pay taxes on whatever profits we get from that. If it's done at a, like a fundraiser, like our holiday party, then that's not a regular thing. So the rules are different for that. But if we set up a storefront, then yeah, we're going to have to probably file a different tax form other than the little credit card or the little postcard one that we file now.
Okay. All right, Brian.
Sorry, trying to flip back to the screen. For the storefront, as far as like collecting taxes and things like that, we would have to get a sales tax and use ID for Pennsylvania. The great thing is you can go right on Pennsylvania Treasury's website, and Terry could probably do this. You can reach out to them with any tax questions for the state, and they'll let you know. I did this recently last month, and I had a couple questions about getting the licensing, if I needed the licensing, and within like an hour and a half, they sent me an email back. It was clear. It wasn't like, here's this 40-page document, go be confused. It was a very clear, cut and dry answer. Now that won't help obviously with the federal side of things, but I'd imagine if we reached out, we can get the answers we need directly from the Treasury and the IRS without really having to go down the rabbit hole and try to track down all this information ourselves and try to interpret it ourselves. Another thing, as far as membership goes, when we do go to NEAF, beyond just going to expand the presence of the 3AP, we are trying to use this as a membership drive. One of the ways we're planning on doing that is we are going to push that, we're one of the largest organizations on the East Coast, and that we have members across the country. We're not just located at this little club in southwestern Pennsylvania. We do a lot of online things, and the biggest thing is our Discord. One thing that we want to reach out to Luis and ask him is, for the week of NEAF or the week following NEAF, is to open up a couple select private channels, what would be considered private to members. have those opened up so people can experience the Discord for about a week. I know I didn't speak to Louise, but talking to John, because he's familiar, John Stump, he's familiar with how Discord works. He said that that would be a very easy transition to open up a couple channels for public view and then to lock them back down after a week.
Okay. All right. Joyce, I see you had your hand up.
Yes, actually, Brian addressed one of the things that I was going to say, that in addition to the federal issue is that if we were selling things, there is the state sales tax issue. But in my experience with 501(c) type things, there also is the overall income threshold. That means you have to fill out different forms than if you're under that income threshold. But what somebody, I had an IRS question, and somebody said to me recently, wait until the tax season is over because you're not going to get a customer service person very easily. But yes, there are, and I know a retired customer service person, and I would think that they would be able to answer some of our questions, like Brian said, that from just contacting the IRS directly that way. But we'll take anybody's information and sift through it and see what we can figure out.
Yeah, like I said, I know there's definitely a will and there's definitely a way on this. And I appreciate everybody chiming in. I do think this is going to be doable. I think at our next executive meeting, this is something that we're going to like bring up and see if we can try to, get a plan for. But, I just wanted to put this out there, generally, just in case anybody else may have experience with this, since, we're hopefully being a growing club and, anybody with the experience, please feel free to, let us know what we need to watch out for, or any advice that we, could generally need.
You never know, because we do have other lives. You never know what people might know something.
Exactly. All righty. Well then, I believe that's all I had for tonight. I'll just, I was gonna say I can open the floor real quick. Ken or Priscilla, did you guys have something? I don't know if your mic's on or not. Ken or Priscilla? I think your mic's turned on, but I'm not hearing anything.
It's showing blocked.
Let's see.
Now it's showing.
Trying to see if I. Yeah, I don't have them muted or anything. Oh, I see Ken now. I can't hear Ken. I'm guessing it's a never mind. All right. Did anybody else have anything for tonight's meeting?
Kristen?
Yes.
I just have one minor problem with that new star party schedule, mainly for Wagman, where I always go, is like now instead of Friday and a Saturday night, we only pick one day and then we don't take the second one for 2 weeks later, right?
I'm sorry. You said pick one day and then the second one 2 weeks later?
Yeah, like the first one would have a Friday night. And then, we always had a Friday, Saturday night together.
Mm-hmm.
Under the new schedule, they changed that. I think every other month it's going to change.
Frank, that was done by Rowan Poole a while back. And I think the idea was so that we could avoid conflicts with Mingo, that we could have one observatory open and not have them both open on the same night.
And we do have 2 nights in a row. It's just only in the summer months. In the early spring and like in September, we do Saturday only most of the time.
Now, the problem I would have had or have under just the one at a time and then 2 weeks later, the Saturday night, is I don't like to leave my equipment, have to sit in the truck for 2 weeks until the second day.
Yeah.
Like now it's Friday, Saturday, that's fine. But there's no way I like to leave my equipment, have to sit in the truck all that time and then to load and unload and load and unload. This old body is wearing out. So it's just liable to cut down on my star parties.
Yeah.
Sorry to say.
Yeah, I do agree with Mike. I was going to say it looks like for the first 2 months, so April and May, actually May has a Friday and Saturday. April's the one that has a Saturday, then a Friday. May's a double. June, and again, I think it was whenever the previous directors and also the current Mingo directors sat down, because that was also another thing too. This was kind of the first time both observatory directors actually sat down and went over the star party season schedule together. And what they were trying to do was coordinate it. So the star parties weren't going to be on top of each other every single month. The other thing was too, like Eric said, was they were trying to do some, not so much full moon and also half crest, whatever moons. So I think they were just trying to do something different with the schedule. Now, since the star parties have been dated for this year, obviously, the cards are already scheduled. We already have them up on the website. We're not going to, most likely we're not going to go through and change that schedule. I mean, this is something that, obviously for your opinion or any of our members' opinions, we can keep in mind for next year. I don't think the what's the word I'm looking for? Like, I don't think at the time when they were scheduling it, they were putting in mind about if it was going to be an inconvenience for anybody, moving their equipment. I think they were trying to make it more convenient so members didn't have to, worry about doubling up on a weekend, going to Mingo versus Wagman, vice versa. And also kind of spreading also the weekends out. Because you figure, it is Pennsylvania. Like, we do hit those weekends where you're taking a chance whether or not the weather's going to be cooperative or not. And at least spreading it out, we kind of also thought it would be a better chance that, maybe we could get some more viewing time, depending on which observatory was going to be open for that star party. But, we can definitely keep that in mind, whenever they go over the stars party schedule for next year for 2026. But for this year, since the party cards have been printed and also since, it's up on the calendar already, we're going to definitely have to, keep with the schedule that we have.
And just looking at the 26th, we're going to bring back something we had at Wagman in past years, which is one moonrise star party, because we have an excellent eastern horizon, and one dark sky, no moon star party, one each next year. So it's kind of complicated. It's never perfect.
Yeah.
Yeah, I only said that because, well, I prefer, going to Wagman, easier to me than I do going down to Mingo and setting up on the grounds down there. Because I like the grounds at Wagman better, even though it's in the light of Pittsburgh. But that's just easier for me at Wagman than doing Mingo.
Okay. All right. Rich, you had your hand up. Did you have something else you needed to add?
I just wanted to say, I don't know if you saw the chat. Ken made a post there about why his hand was up. They are tentatively, I'll quote him, "I wanted to announce a planetarium open house for club members, tentatively April 12th. I'll put on listserv, Discord, GuideStar." Ken, that's at the IUP Planetarium.
Okay, great. Yeah, thank you for pointing that out. I didn't see the chat going, so thank you. So April 12th at the IUP Planetarium. All righty. All right, so I think if there's nothing else that we need to discuss tonight, I'm going to go ahead and motion or ask for a motion to adjourn the meeting. Can I get a motion, please?
Eric Fisher.
Eric, I think you had your hand up.
Yep.
May I have a second?
I'll second.
Rich, second. All right, all those in favor, say yes, thumbs up.
Aye.
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 And
All
thank you
right.
to John Lutzkovich for bringing in a nice guest speaker.
Yes.
Yeah, it was an excellent presentation.
Yeah, thanks, John.
It was. Before we close, John Diller, are we having quaffing? And if so, when and where?
I am looking at the first Friday in March at the Olive Garden in Pleasant Hills.
Oh, okay, where we were.
Yeah.
Thank you. I was kind of in and out of the meeting and I didn't know if I'd missed anything.
Yeah.
Thank you.
A lot of these places I was looking at because I really like them and blah, blah, blah. On Friday nights, they tend to be, they pack them in like cattle. And one of them, at least I know, is that pretty much no soundproofing in it. So it'd be kind of noisy. So I'm discovering what works and what doesn't for these events.
Okay, thanks, John. I was afraid I thought maybe I'd missed something during the meeting. So.
No, thank you for saying that, Mary, because I forgot. So thank you very much. I'm glad you guys can catch me when I forget little things.
Okay.
You'll get the hang of it. You'll get the hang of it.
That really was a good presentation. That was very enjoyable.
Yeah, she did a fantastic job. All right. So I don't believe, were there any objections to adjourning the meeting?
No.
All right. Were there any abstains? All right. Okay. Motion that's accepted for adjournment. Thank you guys so much for joining tonight. I'm sorry it was on Valentine's Day, but maybe this was a good thing because, all the restaurants, the reservations are, 3 hours long at this point. So, we got to astronomy instead. So,
Valentine's
astronomy.
Valentine's Day is for friends too.
Absolutely. All right. So I'm going to stop recording here and